Assalamualaikum and greetings. My name is Nazwa Husna binti Azhar, a final year student of Bachelor of Science Honour of Biology, and today I'm going to present my final year project with the title A Review on Application of Antimicrobial Peptide in Food Packaging under the supervision of Dr. Judith Gisep. In general, we all know that foodborne infection offers serious health hazard, making food safety an international concern. According to Liu 2021, preservatives are used in food and packaging materials in order to guarantee food safety. Thus, this makes antimicrobial food packaging is a must in food industry. AMPs in food packaging integrate bioactive compound in a controlled environment and prolonging packed items' shelf life. As we can see in figure 1, this is AMP's food packaging that contain edible foam for packaging nuts, sweet, and fruits. The figure shows an example of antimicrobial food packaging. With the inclusion of AMP in food packaging, it will extend the shelf life of perishable items such as fish, fruits, and vegetables. Objective: firstly, to evaluate the effectiveness of bacterial and synthetic antimicrobial peptide in maintaining food safety and quality in active packaging system. Secondly, is to determine the effect of adding antimicrobial peptide to food packaging on microbiological contamination and shelf life extension. Research question. First, how does antimicrobial peptide help in maintaining the safety and quality of food? Second, what are the benefits of using antimicrobial peptide in food packaging? Third, what are the most effective antimicrobial peptide used in food packaging? What is AMPs? AMPs are multifunctional effector molecules with direct antibacterial and immunomodulatory action. According to Corrales Urania 2020, they exhibit antibacterial, antifungal, antiviral, and antiparasitic properties against gram-positive and gram-negative bacteria. AMPs are increasingly sought after as potential new antimicrobials for treating microbial infection. How AMPs can be integrated into packaging materials? Firstly, via microorganism. Bacteriocins that known as bactericidal peptides such as nisin that inhibit the development of gram-positive bacteria. Secondly is biosynthesis that is accomplished using DNA recombinant technology, and this technique is seldom used. Thirdly is enzymatic synthesis. Lysozyme hydrolyze gram-positive bacteria by disintegrating insoluble polysaccharide and killing cells. Fourthly is chemical synthesis. It is a common technique in the food packaging sector that involves the formation of peptide bond between amino acids. Nanocarriers for controlled release. Firstly is nano-encapsulation. It releases active agent at regulated rates to protect against degradation, enhances compatibility, and provide controlled release. Next is biopolymeric component that encapsulate bioactive substances due to their low toxicity and antioxidant properties. And chitosan is one of the biopolymer for nano-encapsulation such as essential oil. Thirdly is foam. Foam encapsulate and trap bacteriocin and AMPs. Benefits of AMPs in food packaging. Firstly, AMPs prevent bacteria growth that interact directly on the food surface. It also boosts food safety. AMPs also prolong food shelf life, which food that was kept in AMPs food packaging is unaffected. Classification of AMPs. There are 4 types of AMPs. Let's go through one by one. Firstly, antibacterial peptide kills their target by attacking bacterial membrane and blocking internal mechanism. Secondly, antifungal peptide causing fungal cell membrane integrity to be disrupted and interact with the cell membrane that lead to cell death. Thirdly, antiviral peptide prevent viral fusion with host cell membrane and viral adhesion. Lastly is antiparasitic peptide that important in the battle against parasitic illnesses such as Leishmania species. However, the most effective AMPs is antibacterial peptide because they mostly participate in interaction with microorganisms that finally leads to cell death. Research finding. In a recent study 2012, it shows that AMPs work at low concentration and defend against bacteria, fungi, parasites, and viruses. Their highly cationic nature causes cell membrane breakdown, then it will lead to cell death. In the case study, alpha helical peptide molecules make up the majority of the investigated AMPs, and catalycidin are proven efficient against gram-negative and gram-positive bacteria. The application of AMPs in food packaging. Meat spoilage occur due to microbial infection and lipid oxidation. Thus, niacin and pediosine were used to extend beef product shelf life. Fruits and vegetables are very perishable. Makes yeast can grow in their juices. Hence, essential oil and GT2 peptide can be used to extend storage time and add a refreshing flavor. Fish also spoils quickly due to ammonia and amide chemical. As a result, niacin and microgut can be used to prevent aerobic microbe growth and fishy smell. To wrap things up, AMPs offer potential alternative due to their antibacterial and antifungal properties. AMPs offers potential food preservation and protection against microbial contamination. Several procedures must be developed to analyze antibacterial peptide as effective AMPs in food packaging. Suggestion and recommendation. Modern characterization, molecular biology, and bioengineering method are hoped to improve AMP development and enhance AMP's physicochemical characteristic, with the hope that future research can enhance niacin characteristic and improve food preservation condition. These are the list of references. Thank you.